So, using substitution. The first one you probably could do without substitution. Actually, we'll just go, yeah, we'll do both of them. What I'm going to do is assign something to be a u. So I'm going to effectively change my variable. Du means what's the derivative of u?
Oh,
1 dx. Because the derivative of x is 1, right?
oh, I see.
Okay. So this could be changed to u to the fifth. So I'm doing what's called substitution. I'm taking out my x plus 2, I'm substituting in a u. I'm taking out my dx, I'm taking out whatever's here, and I'm substituting in a du. So this just becomes u to the sixth over 6 plus c. Now I must substitute back in. That wasn't so bad, was it? We're going to do another one that's a little bit worse, but not too much. What do you think I'd want to substitute?
X plus.
For x minus 1. What's the derivative of my u? Derivative of 4x is 4. And anytime I take a derivative, I have my dx. Okay. You usually voted before as du dx, but essentially the dx is just multiplied to the other side. What you did really was this. You divided both sides by dx to have it be more meaningful as a slope. So this is u to the 1/2. Dx is not du though, is it? 1/4 du equals dx. So in place for my dx, I need to substitute a 1/4 du. And there was a rule that you could pull your constants in front. So generally, I just write the second one. Okay. I wrote the first one the first time to show you the rule. I raise the exponent by 1, divide by the new exponent, which is multiplied by its reciprocal. I will reduce that, a 2 from both of those. 2 times 3 is 1/6. U is 4x minus 1 plus c. Not so bad so far. You did a little bit of reversing the chain rule yesterday, but I'm going to show you more. This one you could have done yesterday. What do you think u is? 7x plus 5. Derivative is 7 dx. So that's 1/7 du is equal to dx. So I'll put the 1/7 just in the front. Cosine of u du. The antiderivative of cosine is sine, I believe, correct? Look at your derivative sheet. Make sure.
Did one, in a lesson, we did one that's that.
I was like, I just wanted to make sure it was sign, not negative sign. Not bad, right?
How come we're substituting? Kind of just feels like extra steps to anti-group.
It's not going to be extra steps in a second. I'm substituting right now to show you the steps on the easy ones. And they're not going to be extra in a few minutes. So this one is a 2x, but I have no good way of doing that. Except I know 1 over cosine is secant. Yeah. So the antiderivative of secant is 2 and it's divided by 2, right? Okay. This is the last time you didn't really need the UDU here. But I wanted to show with some of the easy ones that you could probably do without. Now you're gonna need it. So that trig identities trick was helpful, wasn't it? That all of a sudden made that one easy. This one, you don't have anything that's derivative as tangent, do you? But we know from trig identities that it is sine over cosine. And those are derivatives of each other, aren't they? In the case of this, always choose the bottom one. What's the derivative of cosine?
Negative side.
Negative sine. So negative du equals sine x dx. It's a negative here. I replaced the sine x dx with a du. I replaced the cosine x with a u. Negative ln absolute value of cosine of u plus c. This is where it's going to get real. So now I'm substituting back in my cosine. If you get this far, I'll take it. But this is not what the answer key will have.
What will we use?
So the ln of 1 is 0, right? Do you guys kind of remember that from pre-calc?
Yeah.
Natural log crosses the x-axis at 1. So it's 0. So I can just add in a 0, right? So the laws of logs say that now I can combine that. And 1 over cosine is secant. That was kind of a lot, isn't it? There's a lot of things put together in that problem.
No better than great job.
That's what I'm putting in there so that I can Use the laws of logs minuses division. It's using actually a lot of pre-calc in there.
Oh,
And then 1 over cosine trig identity is secant.
very so.
It's very kind of slick, kind of interesting math. This next one, that's actually one of the hardest ones. It is probably the hardest of the examples. Any idea what I would want my u to be on this one?
I'm going to take a guess at x squared plus 2x minus 3.
That is a very good guess because it's correct. It's the thing that's taken to a power. What's the derivative of this? Plus 2. Make sure to use parentheses. That looks kind of similar to that, doesn't it? I'm like, these are similar. I can factor out a 2 and divide, right? If they aren't, you don't get them as problems. Okay? They won't always be quite that convenient, but if the DU's not there, you can't use this method. Okay? And I won't ask you to integrate things that you can't integrate. That makes sense. There's a lot of them. There's books as thick as that red book that are called tables of integrals. That there's really not just a good method to do. If you wanted to integrate it, you literally looked it up in a book. Yeah. Now you just use a calculator, or if you have one that has CAS mode, it can do it. The trig stuff ends up with it off by weird identities usually. But this, when I go to integrate it, is just integral of u squared and 1/2 du. So I get 1/2 u cubed over 3 plus c. Or I always must substitute my x back in unless I'm dealing with a definite integral, which I'll show you one of those coming up. That wasn't so bad, was it? What would be u here? Sine, because that's the one taken to the power. Du is cosine x. And my final answer, I must put the sine back in. Okay? The, it'll be challenging. The first ones that you do are going to tell you what u is. Okay? As you get more practice, you'll have to pick the u's on your own. Tomorrow has a pretty long assignment. You'll have a work day Monday. But yeah, you need a lot of practice to get these down. Like, what is my u? And some of them you're just gonna have to you're gonna get stuck and you're gonna have to ask, what's my u? And then I'll tell you and you'll be like, oh, yeah, that makes sense. But sometimes you have to get stuck. No, easy. What's my U?
The U is on secant.
No, my U is tangent.
Oh,
What's my derivative of tangent?
it's weird.
Uh-huh.
Oh, okay.
Your U, you want its derivative to be sitting there. With sine and cosine, either one is sitting there, so you pick the one with the power. Because tangent's derivative is secant squared. If you do secant squared, you have a complicated derivative and it's not sitting there as U. I'm going to do U of pi over 4. What's tangent of pi over 4? 1. So you could use a calculator for that. Or it's pi over 4 is 45 degrees. 45, 45, 90 right triangle, those are the same. Opposite and adjacent are the same. U of 0, 0 angle is here. Opposite is 0 over adjacent is whatever, is 0. So I'm now going to change my bounds to be in terms of U. You don't have to do it this way. I'll do it the other way too. But it's simply U du. And remember when we have bounds, we plug in upper bound minus lower bound. If you didn't want to change the bounds, you would have to put it back. I think it's actually easier to change the bounds. If you get multiple choice tests later, AP likes to put them in and say, what integral does it match with? And you have to change the bounds. Um, College professors might be hit or miss, depends on what they like. But this would be tangent of pi over 4 squared over 2 minus tangent of 0 squared over 2. Tangent of pi over 4 is 1. 1 squared is 1/2. So you get the same thing either way. I think it's usually easier to just change the bounds. And that's U-substitution. That's reversing the chain rule. You do not reverse the product or the quotient rule in this class. That's for Calc 2.
Huh? He said that yesterday. So I knew it was gonna be.
Coleman's like, I think I'm going into business where I only need Calc 1.
I'm gonna go to art school.
Okay.
I'm gonna